The text transition iExpressions allow you to create interesting transitions from one line of text to another one. We are going to look at 4 of them in total here: the appear, disappear per character, the linear wipe, the random letter wipe, and the really cool looking evolution. And here I've prepared a sample for each of them. So we have 4 text layers, and they all have a keyframed source text, and here the text is set for all of them to "this is my text," and here at the end it's set to "and here comes my new text." And you can see that they all create different kinds of transitions from the one text to the other text. And so what is the general idea of them? The appear, disappear per character, this is this one. This is really easy. It just removes the first text letter by letter and then inserts the new text letter by letter. And in contrast to this, the linear wipe is like overriding the first text with the second one letter by letter. You can see this is your first text here, and then from the left, in this case, letters are overwritten and replaced by letters from the second text. And the random letter wipe involves some random letters in the region that is currently changing. So it's similar to the linear wipe, but you can see if you look at the RAM preview here, you have very quickly changing random letters at the point where currently new elements are inserted. And for this you have really detailed options how this should be looking like, and very flexible different variants. And then we have this evolution text that is like trying to transition from the first text to the second with as little inserting and deletion and replacement operations of letters possible. So for example, this is my text. Now you look at what is happening from left to right. In this case, the text is updated, and elements like this my and text are completely untouched because these also occur in the new text. Yeah, this my and text is completely preserved here, and only the letters in between are manipulated. In other words, the evolution tries to go from one text to the other in as little evolution steps as possible, or in other words, with changing as few characters as possible. But this was just a quick overview. Now let's look at each of them in detail. So for the appear, disappear per character, we start with creating a new text layer and enter there some text like "this is my text." And then, of course, we need transitions, so we need a second text, and we do this by keyframing on the source text property. So we set a keyframe, for example, here at 50 frames, and then at 150 we override our text with "my new text is here." And now we have 2 keyframes, and what After Effects does by default is, since you see here these are hold keyframes, it jumps abruptly from one text to the other one, and this can be changed by all these text transition iExpressions. You just select your source text property, and let me reset this here to the default and apply. Now you can see what is happening is that the first text disappears character by character, and the new text appears character by character. What you now can easily control is in what direction this should happen. So if we, for example, set both of these to right to left and apply it again, you can see that the text appears and disappears now from the other side. Yeah, it's looking like it's coming out of, so it starts with the end of the new text. And this often looks better if you also set the alignment of this text to left to right. Yeah, if we do this left to right and move it over here, then it's like the text isn't moving anymore, but it is appearing and disappearing from this side. Also, this is good when I undo this because I don't want to create a new keyframe. You have to be careful if you change your paragraph alignment here and you are not on a keyframe, then you can see here a new keyframe is created, and this is not what we want. Therefore, we undo this and go to a keyframe, select the source text such that both keyframes are selected, and go here to make a text that is aligned in the center. And then we can also set this here, for example, to center. And now it complains that we currently have not selected the source text property of the text. So let's select this one and apply. And now you can see it disappears to the center and appears also from the center of the text. And finally, what is also quite nice is that you can set it to random. Select it and apply again, and this means the letters appear and disappear in a random order. This means what you have in between is not really a finished part of the word, but there are still everywhere parts missing. So it's like they appear and disappear in a random order. And of course, you can control this for the two directions separately. So you can, for example, let's apply this one here. This makes them disappear to the middle. Center means first here on the right some element is cut off, then on the left, then again on the right and on the left until we are in the center. And when everything is disappeared, now they appear again in random order. For this random order, you can control here the randomness. So the random seed, if you choose another random seed, you get another random order in which the letters here disappear and appear. And if we duplicate this layer, Control D, and move it here, you can see that the random order for this layer and for this layer is not the same, because its change for each layer is marked. If you apply it to both of them again and disable this checkbox here, you can see that they are now using the same randomness. So it's like they have exactly the same random order in which the letters appear and disappear. Okay, that's the appear disappear per character, and let's continue now with the second one, which is the linear wipe. The linear wipe is exactly as all other text transitions too, in that it needs a source text property with keyframes on it. So we have here some text and here some other text simply by creating some keyframes. And if we apply the linear wipe to it, it basically takes the first text and replaces the characters letter by letter by the second text. And you can set the direction here to left to right, right to left, from center to center and random. If we set it to random and apply this one, you can, for example, see that in a random order, the new text letters are override the one from the old text. So this is quite different and very nice way to have this text transition here. And also, if you set it for example, to from center and apply, you will see that the new text starts building now from this region, which is the center region of the text, to the left and to the right until the complete new text appeared. And similarly, you can do from the outside to the center, from right to left. Okay. Then you have alignment. The alignment, it's always a good idea to keep this alignment compatible with the alignment you've chosen here. So, which means currently, or if we set this text here to left aligned, better leave this here also to left aligned. And if we then do here, for example, from left to right, you can see they are nicely replaced here from left to right, and the first letter of this one is replaced by the first letter of the new text. Although the new text has a different length than the old text. If we set this in contrast to right and apply it, then you can see that the first letter here is actually first it jumps. And then you can see that you have here empty spaces inserted. And this is because the alignment is now on the right, which means if the second text is longer than the first one, then if the second text is shorter than the first one, then the first elements of the first text are matched to empty spaces. This looks only good when you also have here the alignment of the text set to right. If we do this, then now it looks again quite natural that here these my letters appear far more to the left than this here. This is because of these additional empty spaces that are inserted here now on the left. So in other words, align might be a bit confusing. The simple answer is set this alignment left, right, center exactly to what you've chosen here at the paragraphs. The more detailed answer is If the two texts have exactly the same length, it doesn't matter at all. If one of them is longer, this alignment tells you how these two texts are placed on top of each other. Then one additional tip, if you have more than two texts that you want to show, yeah? So let's say at this point we want to say, and here text number 3, then you can see it automatically also computes this. Yeah, so you have a first text, then you have a transition to the second text, and then from the second it immediately continues to go to the third text. If the second text should stay like this for a while, you can simply copy this keyframe and paste it here, and then in between this, the text stays as it is. Yeah, by this you can easily then create text transitions from one text to the next, to yet another, and so on, and have regions in between where the text stays as it is. Also, with some trick, you can create a fading in of a text, and this you do by setting an additional keyframe at the beginning, where you just enter an empty text. Yeah, so now at the beginning here we have some empty text, and from this empty text it then transitions to this first text, and then from the first text it continues to transition to the next text, and so on. Okay, the only thing we didn't explain in detail is this randomness here. This is only relevant if you choose for direction here random direction, and then if you don't like the particular random direction that the iExpression has chosen, just change this random seed here and you will get another random direction. And also, if you want to be this random direction for all layers identical, disable this checkbox. Now we come to a more interesting or even more powerful text transition, and this is the one with random letters. Like all other text transition, also the random letter wipe requires a source text of a text layer with keyframes. Yeah, you have different texts. Here we have this is my text, and at this point we have another keyframe where the text changes to my new text is here. And now with the random letter wipe, we simply apply it to the source text, and what it does is the following. It changes the first text to the second text. Maybe we really just look at a RAM preview. It step-by-step rewrites the first text to the second text, and at the point where it is currently rewriting, it inserts random letters that quickly change. Yeah? And you can change the direction in which it does it. So currently it has rewritten the text from left to right. You can also rewrite it from right to left, or you can also rewrite it from the center to the center, or in a random order. Let me just show you the random order, because this one looks also pretty nice. Now you can see that the letters are step-by-step modified until the second text is here. This is in particular nice if you use a font that has a fixed character width, so a fixed width for all letters. Let me just go here to the characters and make sure you have both keyframes highlighted. Otherwise, you just change the font for one of them and set this, for example, to Courier New, which is such a fixed text font. And you can see here that the first that all letters stay as they are, except the ones that are currently rewritten. Yeah, until you arrive at the second text. So pretty nice effect. And again, you can do this also now, let's say from the center, apply. I know it complains that I didn't have selected my source text. So I select the source text and apply. And maybe I enable auto apply, such that from now on all the changes I do here are automatically translated. And now you can see from the center, so this is the center of our text. Yeah, it rewrites to everything to the new text. This alignment here controls, you can see that currently this text here and this second text are left aligned. So this means they both start at the first position here. Yeah. If we set this from left to center, for example, you can see that the first text here is here placed in the middle, yeah, of the new text, which also means that at this point here we have a little jump, and this is because we have set here our paragraph to be left aligned. So if you set this here to center, make sure to also set this here to center and move your text again accordingly, and now this is a seamless transition, yeah, where the new text is in the middle of, or the old text is in the middle of the new text. In other words, make sure to choose by a line whatever alignment you've chosen here. Okay, we've talked about the direction. What we didn't talk about yet are the alphabets. These might be familiar to you if you've watched the tutorials about random texts. So these determine what letters are used for the quickly changing random texts here. You can, for example, also say we want to have binaries. Yeah? And if we look at this, it's a very different look again, because at the positions that are currently changing, you can see you have just zeros and ones that are very quickly changing. And you can choose arbitrary other alphabets here. You can change the size of your random string. This means how many of these random letters do you see here in parallel working on your string, so to speak. This is best understood if we set the direction back to the direction from left to right. You can see that here we have a string of size 3 of these random letters that is rewriting the old text here into the new text here. Yeah. And if you set this width here to 6, for example, this text block is longer, in this case consists of 6 characters. Yeah. And although if you set it back here to instead from left to right to random direction, you don't have one block, so a string of width 6 anymore, but in total you also have here 6 positions with zeros and ones that are changing your old text into your new text. Then if you think that these changes of these random numbers are too quick, you can set your random letter duration here to longer than 1 frame. Yeah? If you set this to 5, for example, and we preview this again, you will see that the zeros and ones change much less quick, yeah, because we've set this now to change only every 5th frame instead of every 1 frame. Oh, and this random string width is of course much too much. Let's put this here to 6 and preview again. And now you can see the zeros and ones change much slower. Okay, the only thing I didn't explain yet is the randomness. This is only relevant if you've chosen here random direction, then you can modify this here to get another random direction, since this is exactly the same as in the other text transitions. I'm not going to explain this here again and go directly to the next text transition, which is a really cool evolution. The evolution iExpression is, in my opinion, really the most powerful and interesting text transition you have in iExpressions. And what it does is it rewrites one text into another text using as little text editing operations as possible. So in this case, I have here a source text property of a text layer with 2 keyframes. Here we have the text "we want fair play," and here we have the text "he likes airplanes." And we want to transition from this first text to this second text, and we apply here the iExpression in order to do so. And now you can see what is happening. The "we" is replaced first by the "he," and then the second word is replaced. And then from the fair play, just the F is removed, and the space is removed, and a few letters at the end are added, and all the remaining parts are preserved. Yeah, so you can see that it's not that every single letter is changed, but many of the letters can be reused for the new text and can be preserved. And this is pretty cool and a pretty nice rewriting effect. Yeah. It looks like really, or what it actually does is really, if you have this first text in a text editor and somebody would ask you, please change this text into this text, but hit the keyboard as few times as possible. Yeah? And this is essentially what is happening here. The iExpression computes a way to preserve as many of the letters as possible, such that you have to insert and delete as little as possible. Okay, to the options. In the edit directions, you can say you edit from left to right. This is what you've seen. And you can also, of course, edit, for example, from right to left. Apply this again, and let me set this here to auto-apply, that the next changes are all happening automatically. And now you can see it starts from the right side and ends at the left side. You can also do it to the center or from the center, and also in a random direction. Yeah, if you look at it now, it changes it in a way that at random positions the changes happen. Also pretty nice effect. Then the edit order. I mean, the operations that are happening here are three different types of operations, namely replacements, deletions, and insertions. Yeah. So for example, if we go back here again to left to right, the first thing that is happening is that this W at the beginning is replaced by an H. Yeah. And then we have something here, these are all also replacements. And now here we have something that a new element is inserted. Yeah, here is an S is added, so an insertion operation. And then we have here this F that is removed, that is deleted. Yeah, so these are the three different operations, and by default all of them happen simultaneously. But you can also say something like first replace everything that needs to be replaced, then delete everything that needs to be deleted, and then insert everything that needs to be inserted. And this looks very different. So you can see now we have here some insertions, and these insertions don't yet make complete sense. Yeah, we have the he like fair plan is the result when the replacements are done. And then if we continue further, you can see now stuff is disappearing, and at the very end, stuff is inserted. If you have texts that do not match so closely as these two, this can get pretty nice effects, because it looks like first you have some random replacements in your text, then your text shrinks down to have only a few characters, and then other characters are inserted, and as by magic, another text that makes sense comes out of it. You can also disallow these replacement operations completely. If we do this, you can see what is happening here is first all the deletions are done, and now we have to do a lot of deletions because we disallowed replacements. So this means every character that is not correct, that is not usable, needs to be first deleted and then reinserted. Yeah, and then now here everything starts being inserted. Yeah, this is now like replacements do not exist, then we delete everything that doesn't match, and then we insert everything that matches. Also a pretty nice effect, because the text shrinks down until only a few letters are left, and then new letters are inserted until the second text appears. Okay, now we have some randomness parameters. These are the same as in all other randomness iExpressions. They just determine, if you choose here in your order a random order, then you can vary here your random seed to get different random orders. And you can also say whether this random order should be exactly the same on identical copies, or if every copy should have a different random. Okay, but now we go a little bit into the advanced section here, and this tells you more precisely. Let me close the scoring here for now. This explains you more precisely. You can really fine-tune how the first text transitions to the second one. And if you want to do that, a good idea to start with is to set the output from final result to alignment. And if you do this, you get a preview of, why isn't this happening? Ah, right. This, if you now go to the transition here, to the transition region, so if you're outside of your transition region, the text looks normal, but if you set it to alignment, in the transition, you don't actually see the transition, but you see a preview of how the two texts are matched to each other. So this is my full composition. And a first thing to note here is that, let me just move this a bit. like this. If you set this here to alignment, make sure that you have chosen a font that has a fixed width, like Courier or Courier New, and also that your paragraph is left aligned. Otherwise, this won't look as nice as it looks here. And what do you see here? We see here the first text, and here the second text, and here you can see how they are matched to each other. Yeah, you can see that the H needs to be inserted because it's not there in the first text, and the W needs to be removed, and the E is reused. Yeah, it doesn't need to be disappeared. And here the likes completely gets inserted, and the want completely gets deleted, and so on. So you can see how the two texts fit together and where the iExpression found similarities. Yeah, so this air is completely preserved, the PLA is completely preserved, and so on. And if you change now your options, you can see how this transition here changes. So if you allow replacements, for example, you can see it gets much closer, much shorter. So now the W is replaced by the H, the E is preserved, the space is preserved, the W is replaced by the L, the A is replaced by the I, and so on. And so now you can easily see when you do changes in your parameters how this affects how the first text goes into the second one. This is obviously a bit advanced, yeah, to read this visualization here and so on. But if you manage to do it, you will be able to fine control your transition even better. And you can even insert something that I called force matches. So this is like, okay, if you want this W here not to match this L, so to be replaced by this L, but you want it to be replaced by this I, yeah, then you can insert a constraint saying that this W, which is a 1, 2, 3, 4th character of the first text, so we set here a 4. You can also look this up here, because this is the first text, yeah, we want fair play. And this here is the second one, he likes airplanes. So you can see this W here is this W, we want. Yeah, this is character number 4. And we force it to be aligned to, say, this I here. He likes. This I is character number 5. We say 4 forced to 5, and if I apply this, look what is happening here. So, like this. Now you can see the W is aligned to the I, so it has forced to match this W to this I. And you see the star here that indicates at this position there is such a constraint. Yeah, and now the transition looks different because the L will be inserted and then the W is replaced by the I, the A by the K, and so on. This is really useful if you want to fine-tune. If you see the transition and say, I want the transition to a bit different, you can add up to 4 different constraints here, which positions of the first string should be matched to which positions of the second string, and everything in between is again automatically done by the tool. Yeah. One last example: if you say this Y here should be aligned to this S, yes, this Y should be replaced by this S in the transition. Then you look up the Y is the 17 and the S is the 18. So we say 17. Oops, 17 matched to 18, like this. And here you get a second constraint, and now these 2 elements need to be deleted in order to make this possible. So just give for individual positions constraints how they are matched, and for the other positions everything is done automatically. Now this was already the advanced part, and now comes the part that I would call the advanced part that really goes very deep into the details of this iExpression, and this is the scoring. As I have said before, you can imagine that the iExpression tries to take the first text and rewrite it into the second text using as little operations as possible. And this was actually a lie, because it is even more specific. It's not that it's trying to use as little operations as possible, but it is based on some cost model. So imagine that you need to transition this first text into this second text, or rewrite this one into this one, and for each insertion or deletion you have to pay $1, and for each replacement of one character by another one, you need to pay $1.5. Yeah? In that case, the iExpression finds the way to transition from the first to the second one that spends the least amount of dollars. Yeah? So it's like you can influence with this here what it prefers. In other words, if we set the replacement cost cheaper, it will prefer probably replacements. And if you make insertion and deletion cost cheaper, it will rather prefer to use insertions and deletions where possible and use less replacement operations. Yeah? And then we have here two bonus, word boundary match bonus and line boundary match bonus. And these are the following. So often it's very nice that we match words to other words. In other words, it's good to match a space to another space. Yeah? And here you can say, if you manage to match one word boundary, so one space symbol to another space symbol, you get a donation of $5 for free. In other words, if the tool managed to find a way to match some space to another space, it's okay if it needs one or two insertions or deletions more that cost a few dollars, but if it gets $5 for matching the two spaces, it will do this when in doubt, so to speak. Yeah. So this means if you have the feeling you want words more accurately be matched to other words, in other words, if the first string has two words and the other one has only one, and it matches these two words to only one, you can change this here and force to match single words to single words only. This is really advanced concept, and don't bother if you don't understand this detail. You can really use 99% this iExpression here without modifying this cost values, but at least in principle you can. Yeah? And similar, you have a bonus to match lines here. So this is if you have multi-line texts and compute transitions. Yeah? Let's say the first text has 3 lines and the second text has also 3 lines. Then you probably would expect that the first line is rewritten to the first line of the second text, and the second line of the first is rewritten to the second of the second text, and the third line of the first one becomes the third line of the second text. But this does not necessarily need to be the case. So it's like the editor that rewrites this first text into the second text could also first delete some line break, and then at another point insert later again some new line. Yeah? But here, this bonus says you get really $500 of this cost model here bonus if you manage to preserve your line breaks. Yeah? Therefore, by default, the iExpression will try to rewrite one line into the corresponding line of the second one, and so on. This is actually even more strongly enforced by this checkbox here, and I would encourage you to leave this checked on, because if you disable it, it might get much slower in the computation. But okay, this was the really advanced, very advanced stuff. Don't bother if you don't understand all the details here. This is already pretty clever, so if you understand reading here this diagram and understand that you can force your certain matches, you can achieve basically 99% of all the fine-tuning that you might want to need without touching the scoring at all. And finally, normally it's perfectly okay if you just put this here to final result. Don't bother about the advanced options at all, and only work with this edit order and edit direction operations to get the transition you're interested in. Okay, that's it for the overview of the text transition iExpressions. I hope you enjoy them, do creative text animations with them, and yeah, see you in the next tutorial.